Hello and welcome to the series where I discuss content delivery networks in detail. I will actually start off with a brief primer of what CDN is all about before I go into in depth around the most popular CDNs that are in existence today and how we actually go about configuring them to give us the best functionality. So let's get started. All right, let's get started with the definition of what a content delivery network really is. So a CDN basically allows you to accelerate the delivery of your data to your end user. Now, what I mean by data is your static data. Static data would include your JavaScript files, your CSS, your images, and for most web applications, if not all, these three things form the bulk of data that gets delivered to the end user. So just speeding this up would make a really positive case for your web app and would generally make your web apps faster. So before we delve into the details of how a CDN works, it's worth looking at the vocabulary that's involved. So whenever you actually talk to someone regarding CDNs, a few important terms get thrown around. It's very important for us to understand those terms, right? So we start off with what a point of presence is. In short, it's called POP. A point of presence is a geographical location containing infrastructure for data replication. So if I were to open up a new CDN company, right, I would want to place my infrastructure in a strategic geographical location. So I might decide that, all right, most of my clients would be around Europe. So maybe I can have a point of presence in France, a point of presence in Italy, and then I can just combine together some cheap servers and get them to cache information for us. So this setup or collection of servers which I'll set at each of the geographical locations, they are known as point of presence. Then edge servers. Edge servers are the actual servers that make up this point of presence. Within each point of presence, there would be multiple edge servers. So what happens if you've got 5 servers operating in one point of presence and one of the servers goes down? You wouldn't want your clients to be deprived of the CDN features in that geographical location. So immediately the next edge server available takes over that load. Generally, if all the servers are up and running, they also balance the load between themselves as well, which obviously has a positive impact on how the whole thing gets delivered to the end users. An origin server is where you actually host your data. So that's like the original place that owns the data. So if I were to build a web application, I might decide on deploying that web application in either the cloud, which means that I might just select one of the regions, such as Australia East or Australia Southeast, which means my data is hosted probably in a machine, in a physical machine that is somewhere in Sydney or Melbourne, right? But that doesn't allow me to replicate all of that information across different geographical locations. So this origin server, which actually has the host data, where you first deploy everything, that's known as the origin server. Another term to actually understand before we discuss CDNs is the latency, right? People generally talk about how it improves latency. So latency is if I'm a client of a web application and I make a request, that request travels to a server, and then the response from the server comes back. So latency is that request I made plus the response I got. So the total time that takes for this round trip is what's called the latency. So a CDN would generally reduce this latency by a huge margin, right? And thus speeding up our web applications. So now let's come back to our fantastic graphic. As you can see on the top right hand corner, let's assume we've got a client, and on the bottom left we've got our origin server. This origin server, in a traditional conventional way would actually host all of our web application assets. So it would have, let's say I've built a site on using React, it would have all my CSS, my images, and then when I actually need to, send that information over to the client makes a request. The request is served via this server all the way to the client. Now, as you can imagine, between the client and the server, there would be, X number of hops coming in between as well, which all add to the latency. So the hops would actually, intercept the request and then forward the request, and then based on, what kind of infrastructure you've got in between, it has the tendency of, slowing down or, increasing the latency of the request. So now imagine if I were to have the same, if I were to own, a collection of infrastructure across further three geographical locations around the client. And these are what we defined earlier as POPs, or point of presence. Each of these point of presence would have the static data, as we spoke about, replicated in all of these geographical locations. So one of these POPs has all these edge servers. So they are, those edge servers are caching that information from the origin server on the bottom left to the top right. This means that across these, in addition to the origin server, across these three locations, my static data is cached. So that means my client, the latency from the client to the data, to the infrastructure that's actually holding the data, is much smaller than it would have been if they were actually requesting the data from the origin server, which means obviously that the website is now going to load quicker. So having said that, right, it all makes sense. It accelerates your website. So there's a definite increase in the speed. But what are some of the other benefits that you can actually derive from CDNs, or what are some of the other benefits that most of the commercial CDNs are providing to clients these days, right? Resiliency is one thing that I probably briefly touched earlier while talking about the edge servers. So what happens if you've got, you've got three geographical locations, all of them were working fine, but then one of the geographical location goes down. What happens then, right? So because you had all that information cached in that other location, it's easy. The client gets that cached information from the next closest CDN location, or next closest POP, if you may. So you've got a fantastic inbuilt resiliency in all of this infrastructure. Then obviously security. With websites these days, it's very easy to very easy for hackers to make a DOS attack. And then what this means is a denial of service attack. So they would, they might have bots running which could ping your website a million times, and then your website starts to respond to those requests, and as a result, it goes down. Basically, can't serve genuine requests. So because you've got these multiple locations, they can easily not only scale up or scale down based on the number of requests coming in, but they also have inbuilt capabilities where they can detect a malicious attempt to basically deface or take your website down. On the other hand, a CDN may also act as a reverse proxy for your website. So what a reverse proxy generally would do is it would intercept the request on behalf of the server, and then pass it over to the server. So to the outside world, the server would appear to be that reverse proxy instead of your actual server. That means your actual IP addresses are hidden from the outside world. This means that if an attacker is trying to exploit some vulnerabilities in your servers, they would really not know your IP addresses to actually go that far. They would only know where the response is coming from, which would probably be the CDN in most cases, right? So having spoken about the benefits, a couple of concepts in CDN that are really important to understand is the pull versus the pull mechanism. Generally, when people talk about CDNs, they're generally talking about pull based mechanism. So in a simple case, what happens is when you make a request to a CDN. Let's say you've got a fantastic CDN deployed. You make a request to the CDN. The CDN, if it doesn't find any data, would reach out to the origin server, and then that origin server would respond with the updated data. Now the edge server inside the POP has got access to that updated data, and that updated data is served to the client, right? So this is the first step when you actually set up the CDN and the edge servers from scratch. They don't really have any data, so the first request comes in. They actually use this mechanism to cache that data. So they're basically pulling the data on request, on demand, from the origin server. Um, the push based mechanism is slightly different, right? You've got what happens in the push based mechanism um, is that you actually push information to the client, and please ignore the heading over there. I got that slightly wrong. In a push based mechanism, what you do is the origin server actually pushes the information to the edge servers without the client asking for it. So it actually preempts what the client is going to ask. So think of it as as you pushing files to maybe Google Drive or OneDrive, right, or your Box account or Dropbox account. So you push those assets up front, and then when the client actually needs that information, the client starts to get that information out of your CDN. So that's the push and pull based mechanism. With that, I'll conclude this video. In the next set of videos, I'll talk about some of the popular CDNs that are available in the market. I'll do a separate video on Microsoft Azure. I'll help you understand how to actually configure an Azure CDN. Then I'll jump off to in the next series. After that, I'll do Cloudflare, and then after that, CloudFront as well. If you've got any comments, please feel free to leave them at the bottom of this video. I'll try to respond. If you've got any suggestions, also feel free to leave them below as well. You can follow me on Twitter. You've got that Twitter handle on mentioned in the slide. And thank you very much. I'll see you next time.